In this video, we are going to evaluate integrals using trig substitution, and particularly with secant. It is important to understand the nature of the trig equation and its associated triangle, so let us discuss these concepts before we begin. We know that secant of an angle takes on the value of the hypotenuse over the adjacent side of the angle. So, filling in our triangle, I will put x for the hypotenuse and a for the adjacent side. Now we can solve for the missing side using Pythagorean theorem. Suppose that we let the missing side be called b. So solving for b, we have a squared plus b squared is equal to x squared, which means that b squared is equal to x squared minus a squared, which means that b is equal to the square root of x squared minus a squared. So filling in the missing side, we have that this is equal to the square root of x squared minus a squared. The side that we solved for is similar to the way a question is presented and is the clue for choosing the secant equation and its associated triangle. Next, we will discuss how to prepare the trig equation for substitution. So the first thing we're going to do is we're going to find x and dx. So we're going to find x and dx. Beginning with our original equation, we have that secant theta is equal to x over a, which means that x is equal to a secant theta, which means that dx is equal to a secant theta tan theta d theta. Next, we are going to find theta and its range. So we're going to find theta and its range. Again, beginning with our original equation, we have secant theta is equal to x over a. And this means that if I were to take inverse secant of both sides, we have secant inverse of secant theta is equal to secant inverse of x over a. So we have theta is equal to secant inverse of x over a. Now, to understand the range of theta, we need to understand the graph of inverse secant. So if I were to draw the graph of inverse secant, it would be as follows. So we have -1 and 1, and we have pi over 2 and pi. We have a horizontal asymptote at pi over 2. We have a point at -1 pi, and the graph will swing out like this. And we also have a point at 1, 0, and the graph will swing out like this. So this is the graph of arc secant. And clearly we see that the domain is from -infinity to 1, union from 1 to infinity. And the range is from 0 to pi over 2, union from pi over 2 to pi. So just clarifying the domain and range, we see that the graph goes from -infinity to 1, and then it skips and goes from 1 to infinity. And for the range, we see that it begins at 0 to pi over 2, not quite touching pi over 2, and from pi over 2, not quite touching pi over 2, to pi. Next, I will show you how to rewrite the integrand using trig substitution. So beginning with the side of the triangle that we solved for, we have the square root of x squared minus a squared is equal to the square root of, well, plugging in the value of x, we have a secant theta squared minus a squared, and that's because x is equal to a secant theta. So this is equal to the square root of a squared secant squared theta minus a squared, and factoring out an a squared, we get that this is equal to a squared times secant squared theta minus 1. Pulling out the a squared, we have the absolute value of a times the square root of secant squared theta minus 1. And since a represents the length of a side of the triangle, a is always positive, so we will say that this is equal to a times the square root of, and using one of our identities, we know that secant squared theta minus 1 is equal to tan squared theta, and the square root of tan squared theta is equal to the absolute value of tan theta, so we have a times the absolute value of tan theta. Now, since theta belongs to the interval from 0 to pi over 2, union pi over 2 to pi, and since tangent of theta is greater than 0 on 0 to pi over 2, and tangent of theta is less than 0 on pi over 2 to pi, we cannot remove the absolute value. Unless further restrictions on x are given. Thus, the square root of x squared minus a squared is equal to a times the absolute value of tan theta. Let us look at our first example. After I work this problem, I will show you a shortcut for solving integrals using trig substitution. So be sure to stick around until the very end. Here we have the integral of the square root of x squared minus 49 over x dx, where x is greater than 1. I'm just going to rewrite this integral so that I know which trig substitution to use. So this is equal to x squared minus 7 squared over x dx. Now, identifying my triangle and my trig equation, we see that this is the secant trig substitution. So we're going to use secant theta is equal to x over 7, and my triangle will be as follows. So here I know that x is the hypotenuse and 7 is the adjacent side, and the opposite side will be x squared minus 49. If you are ever unsure in the future, just be sure to line your triangle up appropriately here and then solve for the missing side. When the missing side matches what you are given in the beginning, you know that you have made the correct substitution. Now we are going to find x and dx. Beginning with the original trig equation, we have that secant theta is equal to x over 7, which means that x is equal to 7 secant theta, which means that dx is equal to 7 secant theta tan theta d theta. Now we're going to find theta and its range. Again, beginning with the original trig equation, we have that secant of theta is equal to x over 7, which means that theta is equal to secant inverse of x over 7, where theta belongs to the interval between 0 and pi over 2, union pi over 2 to pi. Now, since x is greater than 1, then theta is in the first quadrant. This is because if I plug in any number greater than 1 for x, I will obtain an angle located in the first quadrant. Thus, theta belongs to the interval between 0 and pi over 2. Now we are ready to substitute the integrand and plug in the value of dx. So we are going to evaluate the integral. So beginning with our original integral, we have the integral of the square root of x squared minus 49 divided by x dx is equal to the integral of the square root of, well, we said that x was equal to 7 secant theta, so we have 7 secant theta squared minus 49 over 7 secant theta times the value of dx, which was 7 secant theta tan theta d theta. Canceling 7 secant theta with 7 secant theta and squaring 7 secant theta under the square root, we have that this is equal to the integral of the square root of 49 secant squared theta minus 49 times tan theta d theta. And factoring out a 49, we have that this is equal to the integral of the square root of 49 times secant squared theta minus 1 times tan theta d theta, which is equal to the integral of 7 times the square root of secant squared theta minus 1 times tan theta d theta, which is equal to 7 times the integral of the square root of tan squared theta times tan theta d theta, which is equal to 7 times the integral of the absolute value of tan theta times tan theta d theta. Now, since theta belongs to the interval between 0 and pi over 2, we can remove the absolute value. So this is equal to 7 times the integral of tan theta times tan theta d theta, since theta belongs to the integral from 0 to pi over 2. Tangent of theta is greater than 0. Thus, the absolute value of tan theta is equal to tan theta. So this is equal to 7 times the integral of tan squared theta d theta, which is equal to 7 times the integral of secant squared theta minus 1 d theta, which is equal to 7 times tan theta minus theta plus c. So now we need to sub back in the value of tan theta and theta so that our answer will be written in terms of x. So to do that, we need to grab our triangle again. So we have x, 7, and the square root of x squared minus 49. We know that tangent of theta is equal to opposite over adjacent. So that's going to be the square root of x squared minus 49 divided by 7. And theta can be found from the very beginning when we said that secant theta is equal to hypotenuse over adjacent, so that's x over 7, which means that theta is equal to secant inverse of x over 7. So plugging that in, we have that our answer is equal to 7 times the square root of x squared minus 49 over 7 minus secant inverse of x over 7 plus c. Now, how about that shortcut that I told you about in the beginning? So if you just want to look for a quick shortcut, say you have the integral of the square root of x squared minus 49 divided by x dx, where x is greater than 1. After we solve for x and dx, so x is equal to 7 secant theta and dx is equal to 7 secant theta tan theta d theta. So whether you are going the fast way or the short way, you still need to find x and dx. So now for the shortcut, we can simply use the equation that we solved for at the very beginning, which is x squared minus a squared is equal to a absolute value of tan theta. So in our case, the square root of x squared minus 49 is equal to 7 absolute value tan theta. So when we get ready to substitute, I can simply replace 7 absolute value tan theta with this part right here. So we have that this is equal to the integral of 7 absolute value tan theta divided by, and we still need the value of x, which is 7 secant theta, and we still need the value of dx, which is 7 secant theta tan theta d theta. And from here, we can continue just like we did before. So we can cancel 7 secant theta, 7 secant theta, and I can go ahead and remove the absolute value because I know that the range of theta will give me values between 0 and pi over 2. So this will give me 7 integral tan squared theta d theta. And if you see, we're already at this step here. So we were able to skip all of the steps prior to this step here. So you will be able to solve the rest of the problem in a similar manner as before. And that is how you evaluate integrals using trig substitution. Thank you for watching, and I will see you in the next video.